My presentation is going to be related to generating. We are going to make a full system in which we are going to connect an LLM to produce text with a text-to-speech model to produce the speech, with the model to clone our own voice. Okay, and we are going to embed all this into Telegram so we can use it in our phones. So before diving into the code section, I would like to talk about a bit about the specifics, the fundamentals from a very high point of view of the how to work with audio in artificial intelligence, because this is my background. I am a PhD candidate at the Universidad Politécnica de Madrid, and this is what we do every day. But mostly people tend to know about how to work with text, how to work with image, but what about audio? So the first thing I would like you to notice about audio is that, okay, it won't work, okay, so I will point with the hand. It's a massive piece of information. So just 1 second, it's in a CD quality, 44.1 kilo samples of information. That is huge. It's like a super big image, and 1 second of audio is like nothing. Imagine we need to work with 3 minutes for a song, a full song. That's a lot. That's an immense image or a massive textbook. So usually we don't work with this, with the raw audio like that. We usually work with a fundamental small piece of information. That is some information that represents perfectly, or at least a best approach, a best effort of representing the most important characteristics of audio. And that's what we try to use when using artificial intelligence with audio. Let me explain a bit better, because we usually in engineering talk about this scheme, which is first we try to convert this into the smaller piece of information, which is encoding in engineering style, fashion, but it's a funnel. Something big, it's converted into something smaller. Then, to make sure that this piece of information is meaningful, we would like this to reconstruct exactly the same audio as we had in the beginning. It can't be exactly the same, because we are reducing information, but it has to be the most similar possible. Okay? However, I usually like to give this example in class. This is like trying to pass an exam. That's the exam. This is the textbook, which is huge. And this is the cheat sheet that I will keep in my pocket. This is all the information I need to reconstruct, to try to pass the exam. It doesn't need to be a perfect exam, but at least to pass it. Okay? And this piece of information is the one that we usually work with. I also like to comment on the idea of calling it latent, also embedding. This is because, imagine, when working with music, we have some human words that we can use to describe the music, like instrument, rhythm, note, pitch. But AI doesn't understand this. It works with features, with fundamental features that make it work, and when we don't know what it is, we just call it latent, and we are fine with that. Okay, that's why. But today we are working with a text-to-speech model. That's why we need an extra feature here, which is a base speaker model. This is, in my opinion, in the state of the art. This is something that accepts as an input text and will speak it out loud. But this is quite achieved, in my opinion. This works. The problem is that this is a base speaker model. So it will speak like someone that we don't know. But I would like to have some of the characteristics of, for example, a random speaker like me. So I would need something extra, which is another box, which is a color extractor. We call it like that when we want to mean that this is the characteristics of my vocal tract. This is something that is going to understand the characteristics of my voice and try to input them in the latent information, in the fundamental information, but only change the characteristics of the voice, not the information of the voice, only the characteristics. That's why we have these two things. So in here we have the text, in here, we have my voice. And in here, we have the text with my voice. Is that clear? The only extra thing that we have here left is that everywhere we need to have an LLM. There. I'm not going to write down any text to produce the speech, right? An LLM is going to do it for me. I'm just going to input something. And now that we know this is the fundamentals, this is the high-level schematics, to Telegram. Okay? Yeah, and using open source models. So, because today we are here in Mindstone, and Google is one of the sponsors, we are going to use Google Gemma. And for the text-to-speech, that's for the LLM. For the text-to-speech, we are going to use, we have 2 stages. So we have the VITS model, which is a plain text-to-speech, the base one, and then the one that is going to convert my voice, which is the open voice, is in my opinion, quite good. The latest release was 2 weeks ago, so let's see if this works or not. Okay, so let's head to the coding part. I'm going to open PyCharm. That's my IDE, my favorite IDE. Can you see it? Yeah, sorry, I'm going to close this. Okay, so the first thing, the imports, what we are going to use for the LLM is the LangChain. Probably you know about this, it's pretty common these days. For the text-to-speech, don't worry about picturing this because I'm going to share the GitHub afterwards, so don't worry about that. For the text-to-speech, we are going to use the open voice API, and for the Telegram API, right? So I've set some environment variables. The first one is the device. In the case that you have a GPU, this will run faster. In the case you don't, it will work, just slower. And the Telegram token. You need this. I have attached to my presentation a tutorial on how to get this token, because it's quite straightforward, but it's nothing that you can code. It's something that you have to do in Telegram website. So first thing, we're going to code the LLM. We need to set it up and then create the function to generate text. It's super simple to have an LLM these days. With LangChain, I'm using Ollama, which is like a wrapper in which we can HTTP call this server, and then we will receive the resulting text from the, in this case, Gemma model. And the generate text, well, we just call the invoke from the LangChain tools, and then we will receive the resulting text. Super simple. And you can have a lot of more attributes in here, but these are the more simple ones. So you can, when playing with this code around, then you can change this. So second part, that's the text-to-speech stage. This is a bit more tricky because it's 2 stages. So the base one, the one that just speaks out loud in any voice, it's just this line. This is very simple. It's in English and in the device with the GPU or CPU, whatever. But for the colorizer, for the one that is going to change the way that this speech is going to be made by my own voice, this is a bit more tricky because we need 2 things. First, we need the embeddings of the source speaker that was the model trained with. So for taking that, we need to choose one of the ones that they have in the library. I chose this one, which is English, and as you can see, I have a perfect British accent, so I decided to choose the British. And as well, we need to have the source embeddings of my own voice. And for that, I recorded 30 seconds of my voice, which I think I cannot play, but it's just me saying weird things in English, okay? Hello, my name is Mateo, I'm a student, I'd really like to speak in front of you, whatever, okay? Yeah, I need the model to capture my nuances of my voice. This is how we do it. And then for the text-to-speech, this is just the setting up. This is very simple this time. We just need to call the text-to-speech to file model. This is the base one. And we are going to create a temporary file with the speech, with the plain speaker. And then we are going to use this temporary file here to push on top of it my voice with this sentence. So it's not very difficult. It's more difficult to set it up, okay? But this part is very simple. Now, we can head to the Telegram part, which is we need to create an object updater. This is the one that is able to go to the conversation in Telegram and is able to read the message and is able to send messages. So we just need to set a handler, which is these things that, you know, the ones that you write / something and then some input, and it works like it fires some event inside of the code. This is how we do it with a command handler, and then you decide which is the / word, in my case, Mateo. So I can say something like / Mateo, how are you? And I expect Mateo to answer, okay? And the last part is wrap everything up. So we have some text that I've sent to Telegram. Sorry. I have some text that I sent to Telegram. Then I input this text into the generate text function. So I get the LLM response. This response, I'm going to send it to the conversation in Telegram, but I'm going to send it as well to the text-to-speech. Then I will get the audio, and I will send it to Telegram. Do you want to see if it works or not? Okay, it's already running because it takes a bit to set everything up. But I have here, this is my Telegram, I have hidden everything personal. So I can say something like, Mateo, how are you today? Usually it takes, since this is not streaming the text, because in ChatGPT we are very used to have everything like appearing. This will appear just in one message, so it takes a bit longer. It should be like 5 seconds more, nothing else, I think, hopefully. Yeah, there you go. Well, at least he's working optimally, but he doesn't have feelings. That's great. But what about just saying it out loud? Let me prove that I'm doing it. I'm going to receive it in my phone. There you go. Wait.
As a language model, I do not have personal experiences or emotions. However, I am functioning optimally and ready to assist you with any information or task you may have. How can I help you today?
Is it my voice? Not yet, not really, because I'm not British, okay? But in Spanish, it usually works better. But I had to do it in English. So, yeah, that was everything on my side. I'm going to leave you some more, comments here, because, I mean, everything is in the GitHub. So you have here the link to the repo. Here is the tutorial to create the bot in Telegram. Here's how to set up Olama, the server. More information about these guys. And of course, if you have any question, if you want to connect me, if you just want to chat, this is my LinkedIn. The thing that I just shown is like a very simple one. Now the doors are open. It's up to you, whatever you want to create. Thank you.